Ladies and gentlemen, please join us in welcoming our next session to stage.
Okay, all right. Hello. Welcome to Protocol Village. You guys are the best because you guys are the smartest stage. Can I get a shout out for yourselves at the smartest stage? Can I hear a round of applause for you guys? Thank you for being smart. Thank you for being here. You know the devs really set the tone in the crypto world, and that's what it's all about. And that's what this stage is all about. We get more technical. Today we're learning about some really pressing topics for Web3 development. We're going to do a deep dive into some ecosystems in the subsequent days, and we're actually going to kick it off with a deep dive later today with Chainlink, and Sergey from Chainlink is going to be here later, so check that out. Anyway, we're back. Thanks for being here. We're going to dive deep into blockchain data indexing. No one is doing that better than the graph, right? Blockchains are just distributed databases. They create a boatload of data, but you got to make it searchable to make it useful. So that's what the graph is working on. And to hear about how they're tackling this challenge, we're going to hear from Eva Beylin. She is the president of the Graph Foundation. Please welcome her to the stage, and we'll get this thing going. Eva, come on up. Let's hear it. Thank you.
Thank you, Zach. Hello, hello. Hello, hello. Everyone can hear me? Awesome. Thanks for being here. Maybe by a show of hands, who has heard of the graph? Amazing. Wow. Who understands the graph? OK. So I'm here to make that better today. Am I pressing this right? There we go. So today I'm talking about the graph and why and how we're building the data standards for Web3. So first off, what is the graph? Overall, we are a data ecosystem. So not only are we serving the consumers, which are the developers and dApps themselves, that's probably what you're familiar with, but we actually have an ecosystem of stakeholders and contributors that are making this possible. So on the left-hand side, we've got indexers, which are the node operators. They're the ones that are doing the hard work, processing the data. Then we've got curators, who are the ones signaling what high-quality APIs should be served and which are highest priority for indexers. Then we have delegators, which are basically stakers who help indexers scale their operation. They contribute to the economic security of the protocol. And then lastly, consumers, like I mentioned. So really creating an ecosystem that is fully decentralized to make sure that APIs that are being served can't come down, can't be stopped, and that there's jurisdictional diversity as well with hundreds of participants in these categories across the globe. More functionally, the graph is the layer between metrics and applications and the actual smart contracts themselves. So subgraphs are APIs. They're open source. They are standardized schemas and a standardized method of interfacing with blockchain data. So it's a pretty common problem that it's hard to get data from blockchains, regardless of which chain. And we make that really easy. And not only can you build these APIs, but if they're existing, you can use them yourself. So a lot of what we see in the ecosystem is hackathon projects. They don't necessarily have time to build their own subgraph, so they're leveraging the existing Uniswap subgraph or the existing Artblock subgraph. So we're really building a multiplicative ecosystem for devs to build more on smart contracts. We also serve across verticals, so we are not opinionated. In fact, it's the opposite. We're here to make a standard across different categories. And we're seeing dApps across DeFi, DAOs, entertainment, you name it. Some of the more exciting ones recently, I would say, are block explorer-like experiences. So people creating block explorers or ways to access data about a layer 2 chain. Maybe they want to access that state data or understand what's happening under the hood. So really exciting to see that across the board. And here's some examples of those dApps that are currently using the Graph network. So you might know that we have a hosted service, which was the centralized service. That's how the Graph launched, and it's been hosting for years. But our mission has always been to decentralize. So these are just a select few dApps that have already migrated their subgraphs to the network and are being served by the hundreds of indexers, like I mentioned. So what's so good about subgraphs themselves? Number one, they are open source and public. So this means instead of your team rebuilding the exact same API, doing the exact same work as other teams, you don't have to do that. The great thing about this is you also have a lot more knowledge sharing about the actual application or smart contract. So because subgraphs are written in TypeScript, which might be a little easier for Web2 devs to understand if you're a JavaScript dev. Subgraphs are often the actual entry point into Web3, where before you learn Solidity, can you take a look at what those smart contracts are doing and can you query them? And so it's a great way for someone, especially at a hackathon or getting started, to understand, hey, these are the things I can build. And then when you do build your own custom smart contracts, you can build your own subgraph too. No proprietary code. So, this is basically time and money, right? Like a team dedicating developers to building proprietary indexers, having to maintain those is a lot of time. And we've heard things like dev teams having 4 to 10 people just to maintain their indexer, which is insane. So, really what the graph provides is the decentralized network of contributors to uphold your APIs at any point. And that makes sure that not only are those dApps unstoppable, but you also have resiliency, meaning depending on the type of service you want, depending on the latency or the quality of service, you have indexers you can choose from. Composable data. So, because subgraphs themselves are standardized, meaning they're the same across the board, it makes it really easy for developers to build subgraphs on top of subgraphs, subgraphs composed of subgraphs, or even including different data sources. So we actually have something called substreams, which I'll speak a bit about later. But you can have substreams that are powering subgraphs. So, not only are you providing that rich data, but now you're increasing the performance of it. Decentralized and no central points of failure. This is really, I think, why a lot of us are here. Is we're trying to create capture-resistant, censorship-resistant systems, and we've seen this in action, right? So things like Tornado Cache, being taken down by a lot of centralized RPC providers. The goal of the graph network is that anyone can host a subgraph or an API, create access to data, regardless of what a single jurisdiction believes. A more fun example of how that's been interesting is, who here remembers Constitution DAO about a year ago? So in the heat of Constitution DAO, they actually had to switch APIs because they couldn't handle the load because it was so popular. And so they actually launched their subgraph on the network in the middle of their auction, and everything was smooth sailing after. So it really shows that central points of failure are not great at the peak experience or the peak success of a dApp. And lastly, developer efficiency. So again, not only do you not have to dedicate engineers to maintaining the indexer, there really isn't much work at all. If you've built the subgraph, maybe there's some tweaks to it as you iterate on your contracts, but otherwise it's smooth sailing. You use the billing experience, and you don't have to worry about the back end, about which indexers or delegators or curators are serving it. So how are we creating data standards? I went into the subgraph a little bit. Open source subgraphs, they're standardized themselves, schemas that can be replicated across the board. The next way is that we're creating actually standardized subgraphs, meaning we've got a team, Misari, who's one of the core developers of the graph, and they're working on figuring out how to make it easier for projects and dApps to build within their ecosystem. So one thing they realized is the subgraphs for lending protocols are completely different for each protocol, meaning the entities that they create, the way they design the schema, all of it was different. And that makes it really challenging for teams like a Misari or really anyone who wants to query DeFi data to actually do so. So they set out on this journey of standardizing subgraphs to make it much easier and essentially a common language across APIs for each category. One other reason this is interesting is because for the end user, we often look at metrics like TVL, protocol revenue, to figure out whether this project is successful. But if each platform is calculating TVL in a different manner, which is correct? Is there a correct calculation? And we've gotten that feedback directly, people being like, hey, why are there no single APIs that give us the same answer? So really the goal here is to open source these standards, make it collaborative, and Misari started that by creating their own sort of TVL definition, and really it's open to anyone's contributions, it's open on GitHub, and the goal is for the industry as a whole to align on what are the standards of how we're accessing data, how we're defining data, to make it much easier for people to build. The next is efficient streaming. So right now, you can use the graph by running a graph node and using a node operator, or running the node yourself. But one thing we realized is the actual streaming and pulling of data to serve the subgraph is very different across each chain. It's very different even sometimes depending on the smart contract itself. And so one of our other core developer teams, Streaming Fast, actually built something called Firehose. And Firehose is a raw data streaming process that uses a flat files framework to basically make it as easy as possible to pull raw data and then either curate it in specific ways. For example, maybe it's price focused, or to feed subgraphs. So really the goal here is to create a standard of how we even retrieve data in the node layer to make it easier for not only the graph indexers, but really any other node operators in the world to run nodes more efficiently. Cross-chain consistency. So I touched on this a little bit, but the graph supports over 40 chains on our hosted service, and we feel it's our duty to serve developers for whichever chain they want to develop on. Really, it's not our choice, it's not our problem, and we are blockchain agnostic. So one thing we really focus on is how do we unify that experience where maybe a balancer is on multiple chains. How do we make sure that their experience integrating chains subsequently and actually supporting those experiences is consistent? And so subgraphs are consistent across every chain. The integration is consistent. And we're also working on a process to make it easier for new community members to actually propose new chain integrations. So that's really exciting. And lastly is composability. So when you have this many APIs that are standardized, it makes it very easy to create things like a TVL subgraph, something that might be pulling from 10 different DeFi subgraphs or different data sources. And this is really important as Web3, DeFi, all these industries mature, because people want end user products. They want human readable information. Oh no. They want human readable information. And so when you do have composability, it makes sure that the information can be synthesized in a way that's standardized across the developer experience, and we're creating unified experiences for the end users. Diving into this a little deeper, so when we say Messari is creating standardized subgraphs, they're basically trying to standardize the outputs in a way that developers can much more easily integrate APIs and integrate new data sources. So one of the hardest things that we hear for dApps is how do I integrate these new protocols as quickly as I'm able to do in the back end? And so these kinds of standards make it much easier where you might be able to just fork an existing lending subgraph or fork an existing NFT marketplace subgraph and start building from there instead of building from scratch and creating inconsistencies. And here's just an example of people wanting those standards. Like I said, TVL is a big one, protocol revenue. How do we define TVL? How do we define impermanent loss? And can we standardize that? More on the efficient streaming. So raw data streaming via a flat files framework makes sure that not only is the performance better, 100x performance improvement for subgraph syncing, meaning that when you're making upgrades or iterations to the subgraph, instead of taking months, it might take hours to sync the subgraph, depending on the size. But it also means that the indexers themselves are running a much more efficient process. So a lot of what we think about isn't only how do we serve the dApps, but how do we make it as easy as possible for indexers, teams with DevOps, engineering, to actually run that indexer themselves without taking up more compute than is needed. This also opens up new use cases. So subgraphs typically are event-based or call-based, meaning you can't get all information from the blockchain. Typically, it needs to be structured or a result of a smart contract interaction. But substreams actually enable all state data, meaning data that might just be consistently the same, to be pulled. So this is really exciting because it enables us to create better standards across wallets, block explorers, portfolio dApps, anything that kind of needs that static information. And one thing we're doing here to grow the standard is actually working with client teams to integrate Firehose as soon as possible in their stack. So we're chatting with Aragon community, the Geth community, and we actually had Aptos that was able to integrate Firehose, I think, in their V1 because we'd spoken with them and they really reviewed the technology just before their launch. So the goal here, again, is we're really creating the standards across the stack, not just at the API or dApp level. And here's just a little more in depth of what the substreams actually do. So you can see there's standard queries, essentially, across different smart contracts. And imagine that the end state is a prices substream. And then anyone can query this prices substream. And you've basically combined different data sources across smart contracts into one, making it much more efficient for anyone to use. Across the standards, we've already supported over 40 chains. And this is on the hosted service, so we're continuing to migrate those onto the network. And our goal is that the graph actually becomes the unifying layer. So there is a future where maybe instead of interacting with Ethers.js and Remix, for example, maybe you're interacting with a subgraph interface or the subgraph studio in a way that you're able to actually change the data, not only present it through API. So we're really excited to continue working with all these teams to make sure that not only are we just supporting their data, but we're ensuring that their developer communities can grow with the subgraphs as support. And composability really means that all data sources are unified. So instead of it being challenging for a developer to know, okay, here are the prices that I need for this smart contract, here's the balances I need for this one, maybe there's a substream for that. Maybe there is a canonical substream for all DeFi financial information that makes it easier for any developer, any data scientist to query and very quickly analyze the chain. I don't know how much time I have left. Okay. So thinking about the impacts, what does this mean for us as an ecosystem? So we need those consistent metrics. I hear this constantly, institutional investors, people who are sort of on the periphery of Web3, they don't really see the clean picture. And that's because we don't have that clean picture. If you've got 3 different platforms giving you 3 different statistics, how can we be trusted? So, the goal here is that, we're not trying to create centralization, but we are trying to create general consensus across the community on how do we portray those metrics? How do we enable the serving of this data in a way that's standardized for developers? And so thinking about TVL as kind of the main one, but where else is this important? Price oracles need to be super efficient. They need to be super accurate. You can't have different standards across different kinds of price oracles. And there's probably a whole other world outside of DeFi that we can explore. Shared ecosystem of plug-and-play APIs. So again, because the graph is open source, it means that anyone can use these APIs. So we're really empowering teams to work together instead of competing. And this means that sometimes someone else's subgraph is actually better for your project. So we've had cases where members of our DAOs will build subgraphs, and then the official teams will start to use them because it just happened to be better than the one that the developer had built in-house. And that's really a consequence or a nice feature of being open source. And it ensures that teams can actually spend that time doing other things like improving their products rather than building redundant APIs. Greater data efficiency, I think I've kind of touched on this a few times. Our goal really is to make sure, just regardless of the type of user you are, whether you're a developer today or maybe data scientist tomorrow, that any kind of data service is really here on the graph. And lastly, consistent sources for retrieval. So this one's really interesting. Everyone's been very excited about AI, and what does the graph have to do with it? And we think of ourselves as the foundation of data access, right? So the actual retrieval in the back end is using something like a fire hose or substreams. Then you're maybe using substreams or subgraphs to access that data at the developer layer. And then you're building all kinds of fun applications, models, analytics, whatever you're thinking on top. And so if we're able to standardize the way that data is queried, whether it's by a subgraph or other methods, it makes it really easy for AI, language learning models, and any kinds of sort of analytics retrieval methods to really build out cool applications. So we're excited to see, different kinds of Dune analytics-like platforms, more complex data in Messari, seeing how maybe NFT data, can actually transition if there are these kind of standardized processes. One thing that we just recently supported is called file data sources, which enables indexing of IPFS, Arweave, and HTTPS data. So that means all NFT data. And is there a world where maybe AI is working on top of that NFT data based off of the graph to create new kinds of art. And maybe there's really cool processes here that we haven't even thought of that can be done once you have data standards. So here's just a view of how we're seeing the adoption of our standards. This is the network, so not the hosted service. But we're seeing really consistent growth quarter over quarter. We've got one of our core developer teams, Edge and Node, that's really focused on the migration effort. So we're helping teams migrate by actually holding their hand through the process, educating them, and then also providing migration grants for any dApps that are looking to migrate their subgraph from the hosted service to the network. Another view from Masari of Q4. And what's really exciting to me, from this graph, just timing-wise, I think Luna and Terra happened Q2. So there might be a story here about how teams are really picking up on decentralization. They understand why it's important, especially with some of the regulatory crackdowns in the last few months. We really believe that the graph is here, as a layer to support dApps from, being taken down. We don't think that this is a risk that dApp developers should take on themselves. And just like the internet is a distributed network of contributors, is there a distributed way for us to showcase data in a way that can't be censored and can't be captured? Thinking globally, we've got hundreds of contributors around the world. This year, we're really focusing a lot more on Asia, as we did South America last year. And so if anyone wants to get more involved, especially in China, India, Vietnam, and Thailand, that's where our graph advocates community is really focused on, as well as Africa. But really just wanted to highlight that everyone here is working together on these standards. This isn't like one team in San Francisco. This is hundreds of participants around the globe that really understand why we need this as base infrastructure. And here's just a shot of our core developer team. So we've got over 6 teams working on the graph full time. These vary from AI experts to GraphQL experts. Oops, again, to graph node and engineering experts. And they work across different working groups. So one of the cool things about the graph is how multidisciplinary it is. It's not just a node development team. We've got a snark force that's focusing on cryptography. We've got the protocol econ team. So a lot of ways for people to get involved, regardless of sort of your engineering background. And that's it. Thank you so much, and hope you get involved.
Thanks, Eva.